Hi everybody, my name is Borislav Borisov and welcome to the course of creating your first decentralized application. Before making it, I tried to do a decentralized application with different front-end technologies like React, Angular and Vue.js, and I found Vue.js to be the most suitable framework for the job. It has a lot less steep learning curve than the others. Before beginning of the course, I want to make a few clarifications. As stated in the description, it requires a basic knowledge in the following technologies. First one, JavaScript and more specifically Vue.js framework. You need to know how Ethereum blockchain works, what is a block, a transaction, why we wait when we make a transaction, and what is mining. And as a third point, basic knowledge in Solidity. However, we are going to create simple contract for our application. So as I stated at the bottom, the course is not suitable for absolute beginners. After this clarification, we can start creating our first decentralized application. So at first I want to show you the final decentralized application written in Vue.js and powered by smart contracts. We have installed MetaMask in order to send transaction to the smart contract. We are able to change the name of every person's account. For example, if I want to write Johnny, which is 20 years old and safe, the MetaMask asks us to confirm the transaction, and once it's confirmed, we are printing success. And if we refresh the page, the data persists, and as well we are able to change accounts like in real application. Users like log out and change accounts, so basically this is the same functionality, but here we keep the data on the smart contract. As you can see, we are changing the accounts and the data persists between them. There's no like server-side database or anything. We're just making a calls to our contracts. Okay, so in the next video I'm gonna show you how it's done. The first step after seeing our first decentralized application is to write the smart contract. For that reason, we need to go into the Solidity editor, which is located at remix.ethereum.org. Once it's opened, you can see here that my contract that I wrote earlier persists. So I would just need to remove it, if it's possible, of course, because it's compiling and all that kind of stuff. So okay, let's start fresh. So the first thing to do is to write the version of the Solidity compiler that we're gonna use. So at that time I'm gonna use Pragma Solidity, which is version 0.4.0. That way you're telling Remix which version of the compiler to use, and by default in some versions of the compiler you can use certain functions, in other versions you cannot use them. So basically that's the obvious way that we have versions. So the first thing to do is to specify our goal. So our goal is to write a smart contract, and basically each account supposed to have its own data. Like you said in the final application, each account needs to hold name and value. So for example, if we have account number 1, it needs to have let's say an object of some name and age, for example 10, and the second account is the same. So we need to come up with some structure in order to keep data in our contract. Okay, so let's start. I think the best structure here to use is a struct. So I'm gonna show you how to utilize these data structures. So basically, I'm gonna write like this contract word is like a class in every other programming language. So we're gonna type storage, the name of our contract. We're gonna type storage contract, and we'll create one struct called person. So this struct person will hold each person data, and we are gonna push to it when a person wants to add or update his data, because obviously he needs to update it as well. So the struct will be from string name and unsigned integer. Here you have different kinds of sizes of bits, but I'm gonna use the default uint unsigned integer, which is h. And here I forgot to use this kind of syntax in the end. And this is our struct, and in order to map it to an address like I showed you before, because this is the address of the person, and you need to map every address to a specific person. So basically this is as easy as typing mapping address. This is a specific keyword in Solidity. It holds the address of the person, and we are gonna map it to person. And like we reviewed before the access modifiers, we want to make this public and call it people. Later, if for some reason we want to keep track of all addresses that we have here in the people mapping, we need to create an array of type address and just make it public and give it a name of people addresses. The reason I'm making this is because in the people mapping you cannot tell how much items it has, and that's why we are creating a separate address array and increment it every time a person adds a new data to the mapping. So how to create our set data function? I'm gonna write function set data, and as an argument it will accept string name and uint age. This is the name of the person and his age. And of course we want this function to be invocable from our JavaScript frontend. That's why I'm gonna set it as public, and we're gonna write the body of the function. So we need to create one element. We need to initialize one element of the struct by writing person, new person equals person, and here in parentheses we need to pass the name like we specified here. We need to create one instance of this struct, and we need to pass the name and the age of this particular person. So that's how we do it. And later on we need to push this new person object into our people mapping, and that's how we're gonna do it. We need to push it, but what should we write here? Like we reviewed before, and in the beginning of this series I told you that each mapping key is the address and the value is the person data. So basically what we need to type as a key here is the person address. And from the previous video probably you remember that we can get the person address by typing msg sender. This will give the address of the person who's making the transaction. So basically this is the sender. And after that, if we want we can push it into the people address. Actually, let's go with addresses, people addresses, and we're gonna push the address like that. And later on, if you want to get all addresses of the people who store the data in our contract, we can retrieve the count or a particular address from there. Okay, so we can proceed with the next step, which is creating a function that can fetch each individual person data. So basically we can write function get person data, and as an argument it needs to accept the address of the person. So as you can remember from before, the address is represented by the address keyword, and this is a good practice to write underscore address because it's a local variable. And then we want this function to be invoked from our JavaScript. We write public for that. As you remember, you need to specify if the function modifies the data or not. Currently, this function doesn't modify the data and just returns data. So that's why we type view, and we need to specify what's the return data from the function. So we specify string and uint. it stands for the name and for the age. Okay, so the signature of our function is done. So we go into the body of it, and the body is quite shorter because we need to return uh, the following thing. We need to return, okay, let's make it like that. We need to return from the people mapping, we need to go into the address section, to the address key. That means go to this specific key in this mapping and just get the name, and go to this specific key and get the age. So by default, if the address is not included in the mapping, it will return just like the default data. For string, it's the default value. For string, it's empty string, and for uint is a 0. Okay, so now when our contract compiles, actually, yeah, it compiles automatically. It says warning, variable is declared as a storage provider. Use an explicit storage provider keyword to silence this warning. Okay, we're gonna fix this error in the next video. Okay, so in the video before we saw that there's an error with our struct here, with our instance of the struct. So basically what it says that the variable is declared as a storage provider. Okay, so there you need to know one thing. In Solidity, the variables are stored like in few different areas. So the first area is the storage, where all the contract state variable live. For example, here, like the person, the mapping, the addresses, which is an array, these are all storage variables. And like I said, every contract has its own storage, and it is persistent between function calls, and it's quite expensive to use. So basically, this data will always be in the contract, and you can fetch it, retrieve it, modify it from different functions in our contract. And the second area is the memory one. So basically, the memory one is used to hold temporary values. It is erased between function calls, and it's cheaper to use. So basically, memory area is for temporary variables. The third one is the stack, which is used to hold small local variables. It is almost free to use, but it can handle only a limited amount of values. So basically, we need to tell Solidity that we want this variable to be a memory one, because it's a temporary variable, and the error will be gone if we hit the button start to compile. I don't know why it doesn't compile every time, but this is how we fix our error. So in the next video, we will proceed with deploying our contract and interacting with it. So once we have our contract in a good shape, it's written well with a few functions, we can hit start to compile if it's not compiled yet. And on the right hand side here, you can see the second tab is called Run. We can tap into the Run section here, and there's different kind of environments. What injected Web3? It's the injected Web3. It's what it says. It's the injected Web3 from the MetaMask extension here. Every time MetaMask injects a Web3 variable into the page, and basically this is the injected Web3, which is provided from MetaMask. Currently, we don't want to use the injected Web3 from MetaMask, which, by the way, can be hooked into the, as you can see, to a private network. It can be hooked into the main network and other test networks. I'm going to show you later how this works, but for now we want to use the JavaScript VM. Basically, it is the small virtual machine into the remix, and basically it has unlimited amount of ether. So what can we do? As you can see, there's like different accounts. We can change and use each one of them. So what we want to do, we can see here that a list of our compiled contracts. We can deploy our contract here by hitting the deploy button, and immediately you can see that our first account balance is a little bit less from 100. That's because deploying a contract costs ether. Every kind of operation which modifies the blockchain costs ether, so that's why we are getting less ether in our balance. So as you can see, the deployed contract, it's here. We can see where is deployed to, the address 692, so we can make it bigger. We can see our functions. We see the set data that we made. We see the get person data that we made, and this is a surprise. We have even a function called people, and we have it because we specified the mapping as a public variable. Every time you specify a mapping as a public variable, it creates a function for you out of the box. And as well for the people addresses, it created a function for it. So basically, in the next video, we're gonna test the contract and interact with it. How can we interact with our contract? This is as simple as just filling the data here in the inputs and waiting to transactions to complete. So basically, if we want to set data for our first account, for example, let's write Johnny 20. We need to hit transact, which says the function is not payable. That means that we are gonna pay only gas for it, and we are not required to send any other value. So okay, I'm gonna hit transact, and as you can see, we are modifying the contract, and what it does, it creates a new instance of the struct with the name and age, and then add it to our mapping, and the key is our address. And the second thing to do is that it pushes it to the people addresses array. So if we want to see if our data is in the mapping, we can try to copy our address from here. You see the little icon, copy address to the clipboard, and go to get person data. Basically what it does, it goes into our mapping by the key of our address, and it returns the name and the age. Yeah, as you can see, Johnny and the age of 20 is there. But for now, we are not sure how many addresses there are in the struct. So I think it's a good exercise to write one more function and to see how can we retrieve all addresses, because in the moment it's not possible with the mapping to retrieve all keys for it. That's why we need to push the keys to a separate array. Okay, so let's write one function to practice our smart contract skills. So let's say the function is called get people addresses, and it's a public view. It doesn't modify the data in the contract, and returns array of addresses. Okay, it returns array of addresses, and here we can return the people addresses. That's all. We can click this little icon here and say clear all instances of the deployed contract. Basically, when we make a modification of the contract, each time we make a modification, we need to redeploy it. We cannot use the old contract. I mean, you can use it, but you need to make you need to make your contract upgradable. Right now we are not making it, we're just redeploying it once again in order to see our change. So in the next video we are gonna see how to redeploy the contract. We can redeploy the contract by clicking the recycle bin here and just going into the compile tab and making sure to hit the start to compile button, because sometimes it's not doing auto compile. That's why I want to make sure everything works correctly. And next thing to do is go into the run section and hit deploy again. It will deploy again our contract, and this time we have get people addresses function. Okay, we can once again make sure that the first account is selected. We can write John here, which is 20 years old. Go into the transact. It finished successfully. We can make sure that we can get the person data by providing the address. As you can see, it returns string and uint. which is John and 20. And if we want to see which address it corresponds to, we can go into the get people address function and just click on the button here, and it returns the address of the person who just created this record. Okay, to make sure it works correctly, one more time, we can go into the second account and set the data for the second account, let's say Mary, which is 28 years old. The transaction is successful. We can copy the address of Mary and see if the data is saved correctly. As you can see, Mary is 28. And at the last step, we want to make sure that there's one more record in this people addresses array, and it's here. This is the address of Mary, and this is the address of John. So as we can see, the contract is working. The only thing remaining is to create a decentralized application. I'm gonna use Vue.js for our front end, and it will talk with the smart contract through the Web3 library. So here is our contract. We're gonna try to create a simple dApp, which means decentralized application powered by Vue.js. First thing to do is to go to our terminal and make a folder called simple dApp. Later we need to go into the folder and type truffle init, which will create configuration files in order to migrate our contract. So we're gonna, right now, as you can see, the folder is empty. When we type truffle init, it's gonna create a few directories. One is contracts, migration, test, and the config files for our migration. I'm gonna power the PHP Storm in order to go and edit the configuration. Here we go. On the left bar here, we can go into the truffle JS file, and in order to set up a migration to our development blockchain, aka the local one that comes from Truffle, we need to edit this config. So basically we need to add following fields: network, then development, and I'm gonna write the host of our local blockchain. You need to specify the port. The default one for Truffle test RPC is 9545, and as well you need to specify network ID 2. And now we'll go into the terminal again and try to create our Vue.js dApp. We are in the terminal now, and what can we do is to init our Vue.js application by typing the command vue init. we need to specify like the webpack template and the project that we want to name it. So currently I want to create a project in the current directory, so I will type dot. This asks me if I want in the current directory. Okay, it's downloading the webpack template. Right now we are seeing like few questions from view, asking the project description, the author. Here we can choose runtime and compiler. Do we want view router? Of course. We don't want ESLint, no tests, no Nightwatch, and I suggest you to use Yarn. And right now it's downloading the template. Okay, the template is ready. So we can see that our application is set up. We need to install a few more things in order to make it better. The first one is Vuex. So type yarn at Vuex. We will need to use Web3 in order to communicate with our smart contract. So I'll type Web3. We're gonna use version 1, and I'm gonna specify the exact version of Web3 I'm gonna use, beta 26, and we will need one more library in order to interact with our contract, and this is Truffle contract. So we're gonna install those. We'll wait for the installation. Here it asks us about some cannot find Web3 that matches the version 36. Okay, I'm gonna choose the first result and we'll wait. The installation is done. So we need one more final thing in order to write better CSS, or to not write CSS though. We're gonna install one thing called Tailwind CSS. It's a framework for writing utility first CSS. Of course, you can get CDN and npm install. We can get the CDN one because we are not gonna modify the config files of Tailwind. So the easiest thing to do is to go into the index.html and just include it. There, and once it's done we can start our server. We'll type yarn dev and wait the project to build. So our server is development server is running on port 8082. We'll go and see if it's live. Yes, currently we can see the main page of the Vue.js application. We can go in the Hello World component and just delete everything between the braces in order to make it smaller and say welcome to my first my first Vue.js dApp. So, in order to see if Tailwind is running, we can change the text cover of these essential links tag. So basically, I'll type text orange to see if it's running. Yes, you can see that it automatically refresh the page because it has the feature hot reload. You can see it's blue, and we can make it orange again. The second thing to do is to go to our tutorials section and simple dApp and run truffle develop. This is the very important thing to do because it will run our local test RPC, and that's how we're gonna deploy our contract. But I forgot one thing to do. So basically, just before we run the truffle develop, we need to create a migration for our contract. So we can type truffle create migration deploy contract, and as you can see, in the migrations folder it creates deploy contract migration. Right now we need to copy the contract from Remix into this contracts folder and later migrate it via this migration. So that's how we're gonna do it. I'm currently copying the contract. I'll create a new file here and call it storage contract.sol from Solidity. Okay, everything looks good, and we are going here, and the first thing to do is to import the contract, actually the artifact. So I'm gonna type const storage contract equals artifacts require storage contract. Basically, it will compile our contract, and the compiled version of it will be available through the this require function. And then we need to say deployer, like in this initial migration, deployer deploy storage contract. Okay, so once this is ready, we can invoke our migrate command. We can go into the truffle develop. It will power up the console. Here you can see all the accounts and all the private keys, as well as the mnemonic phrase. So right now I'm gonna type migrate. This will compile our contracts and deploy them. And the deployed version of it, you can think as creating a new instance of the contract. So basically our contract is like in the programming languages, it's like a class, and deploying the contract actually creates an instance of this class. And this is the address of our storage contract. So next thing to do is maybe to install MetaMask. We can skip it for later, but why not now? Okay, so basically I will remove the MetaMask from my Chrome and simply type MetaMask Chrome extension. I'll click on the first link and then add to Chrome. Okay, so once that's done, here it asks about do we want to try some new version of MetaMask? Of course, why not? Yeah, it pops out a new window, but we can close it and just go from here. Continue. The important stuff here is that we are using mnemonic, which is already generated, so we can skip the creating a new password thing and just go into the import with seed phrase. We can copy the mnemonic and type a password, import. Of course, everybody uses terms of use, so just click accept, and currently by default we are going to main Ethereum network. Here we can change the network by clicking on the different rows. Currently we want to switch to our custom test RPC Truffle network, so we can type the address here manually. So type localhost and specify the port 9545, click save, and right now we are on this network, as you can see. We can verify it by checking the address 6273. It starts with 6273. Yeah, this is the exact address, 6273. As well, we can go to the create account section and create a second account and verify its address F17F. F17F. So basically, if I keep creating accounts, it will just pick up the next account from this list. Okay, so let's return to the first one. So the next thing to do is to create a contracts folder into our application. Contracts folder, and inside I'll create a index.js file. We're creating this file in order to make the communication better from our JavaScript to our smart contract by utilizing the library Truffle contract. So that's how we're gonna do it. So import contract from Truffle contract. Right now we are gonna import as well storage artifact from, we're gonna import the storage artifact from the build, from our build directory, which is this one. You can see that the contract name is storage, and the ABI is like the interface of the contract. It says what are the inputs, for example, the name is from type address, what is the output of the functions, the people, as you can remember, it was array. Actually, it was a struct. The people was a collection of structs which has a person, which has each person has a name and age. So basically, this is like an interface of our smart contract. So we are importing this as an artifact. Currently, we are in the contracts folder. Here, we need to go one folder up and one folder up, and then go into the builds directory. So one more time up, and then build directory and storage contract, and close the braces. I think we don't need to close the braces. Yeah. Okay, I'll bring this on one row, and okay, we imported everything. We will create a storage contract variable which is equal to the contract storage artifact. So basically this is like saying, like in other programming languages, my object equals new object. So basically this is the current instance. This is the current instance for the contract, and we're gonna use it in our JavaScript. Right now I'm gonna type export storage contract. Okay, let's type it with capital letters. That's even better. The next thing to do is maybe rename our hello world component, because the name is not so appropriate. We can rename it by going like that and refactor contract.view. Okay. Of course, it's used in other places, like here. I'm gonna rename it as well, because otherwise there are gonna be errors. And if I can remember correctly, I already added Vuex, so why don't we just create one simple store? So I'm gonna create a store folder, and inside I'm gonna create index.js. So how simple store looks like: in order to keep a central state, we're gonna include view from view. I'm gonna include as well Vuex from Vuex. In order to use Web3 to communicate with our smart contract, I'm gonna include it here, because we are gonna make a calls to the contract. What else? Probably I'll need one more thing for our mutations. It's a good practice to keep it in a separate file. So basically I'll create it afterwards. Mutation types. And the next thing is our contract instance. Storage contract. Okay, it imported it manually automatically. Okay, so maybe it's good to create our mutations here, mutations type. I already know that we're gonna have at least one mutation, which is gonna be, I'm gonna export const update account, and I'm gonna name it update account. Okay, we can return and continue with next stuff for our store. We can tell Vue to use Vuex as a store and create some state getters, actions, and mutations. So first we're gonna create the state. It is an object. Later we can create getters as well as an object. We can create actions, and we will need mutations. And last but not least, we need to export our store instance. Vuex, we'll type store, and in parentheses we need to specify the state, we need to specify the getters, mutations, and actions. And in order to add the store to the Vue, it's we need one more thing. We can go here into the main.js app file and import store from store. Down here we'll just use this store and hook it into the Vue instance. Okay, so the next thing to do is to think how our state will behave. For sure we will have account, and we can think of something else later. Okay, so model not found. What exactly show this? It says the relative model was not found, build storage contract. Okay, so we'll need to go to this contract. Maybe I forgot to type the contracts folder. Yeah, now it compiles. So we are right on track. We have account in our state. This will be our account, and now we need to initialize Web3 in order to fetch our account. So basically I'll create a contract called init Web3. We want to dispatch some action afterwards and open the braces. So basically how Web3 functions is that when we go to our simple application and go to the console, by default MetaMask injects into the web page this Web3 variable, which is, as you can see, it's injected into the window. So basically if I type window.web3, it's the same variable, and it has one property called current provider, which is very important. It says to which network are we hooked in. So basically if I change my network to, let's say, main network, and the current provider object will point to the main network. So our goal is to use Web3, the latest Web3 library, with the provider that is provided by this injected Web3 from MetaMask. So basically, what's our goal is to check if type of Web3 is undefined, and if it's not undefined, this means that Web3 that MetaMask already injected Web3 into our page. So we're just gonna change this injected Web3. We're gonna swap it with our own brand new latest version of Web3, because usually MetaMask uses some older version of Web3, but we want to use 1.0, which is currently in beta. Okay, and in the constructor we're gonna type Web3 current provider. This means use the Web3 that we just installed, but use as well the current provider provided by MetaMask. This means that we're gonna be connected to our local test network. Okay, so later, after that, we want to dispatch an action which is watch Web3 account, because the goal of our decentralized application is to swap accounts and just have different data appear for different accounts. So basically we need to watch it by some like set interval function, watch it, and then change our state based on that current account. So basically we're gonna create another method called watch Web3 account. Okay, and as arguments we want to commit mutation, dispatch an actions, and get access to the state. This is some default Vue.x techniques. So here in this function we want to set an interval in order to fetch the current account of this MetaMask. So basically we are gonna use the function set interval. Okay, the interval will be, let's say, half a second, and we want to invoke the following logic. The first thing to do is to get a count from Web3. This is the library that we're using, Ethereum, and the function is called getAccounts, but I can see that it returns a promise. I'm gonna still use it, but in order to not chain functions and utilize async await technique, we can type await here in order to wait for it, wait for the promise to resolve. And in order to do that, we need to add here async, because you can use await only in functions that in front of them they have a sync. So basically JavaScript know how to stop and wait for the action to resolve. Okay, so the next thing to do is to get like the variable for the active account, which is accounts 0. Okay, and we probably need to make one easy check. If active account is not available, then just return. Later on, we can check if active account is different than the state account. This means that we have changed accounts. So once we have changed accounts, we can commit a mutation. We already created that one. We can create a mutation, commit a mutation, sorry, update account with our active account. This will swap our account with the most current one. Okay, why don't we add the mutation here for setting the accounts? We can type update account. The first thing to accept is the state. The second is the account that want to change to, and type state account equals account. So once that's done, we can create a getter in order to show the account on our main page. We can type account state account. Here we are using arrow functions, and we can go to our contracts view and just create simple computed property and import map getters from Vuex. We'll use map getters in order to utilize shorter functions. Map getters, here it accepts an array of getters we want to use. Basically, we don't want to change the names of the getters here, so that's why I'm using the array syntax. I can show you later the other one. So basically here I'm saying just get the account from our state, and it will return the current account to our template. Okay, I'll just swap this with account and add curly braces, and if everything is done right, we should see our account changed on every MetaMask change. Okay, right now there's some issue with it, so I'm gonna try to debug what's happening. I think there's a problem because it says unused function web3. Maybe we forgot to use this function. Okay, the most obvious way to use it is in the mount method of our initial view template. So mounted methods. Here we can type store dispatch init web3, and as you can see, we are receiving the account, and it's refreshing. It fetches the accounts from MetaMask every half a second. Okay, so let's try to change the account right now. Yes, as you can see, it's the change is here, and yeah, let's continue with the next step. So the next step is to create, like in the contract, if you remember, I'll go into the SOL contract. Every person has a name and age, and we were able to set the data for each person and get his data. So basically we're gonna create two inputs and try to update and view the data for each account. Okay, so the next step is going into the store, more specifically here into the state, type name and age. We can create getters as well, just not to forget. Name, here I forgot, and age, state, age. Once it's done, we can go and create our form in order to use it, to use the function set data. Okay, so we are gonna create name and we are gonna have an input. Yes, and we are gonna have age and as well an input. Okay, let's see how it looks on the screen. As you can see, the inputs are invisible and you cannot see them, and we are gonna use right now the utility first framework that we installed earlier. It's called Tailwind CSS. So basically what I will do is just try to create border 2 pixels with a gray color, and let's try to create what, 1 pixel. No, 1 pixel is invisible, so let's create with 2, but with light. Yeah, that's good. We will want 2 pixels top and bottom, and padding, and 2 pixels left and right. Okay, let's see how that looks. This looks good. Maybe we'll need margin left and margin right. So this is combined by typing mx. Okay, so once that's done, we can copy it to the next one, and as you can see, we have 2 inputs styled, and we are ready for our button. Once we have the inputs, we can create our button by saying save. Of course, this will create some ordinary button, but we can make it look better by Tailwind CSS. We can say BG it will make the button background teal. Of course, we can put padding, top and bottom, left and right. Now the button looks better. We can put text white. Now it gets even better. Rounded corners. They're not so sharp now, and on hover we can say that the background changes to BGTU light. Let's see how it looks. Yeah, this looks better. And of course I forgot. Actually, it's okay. I forgot to wrap it in a div tag in order to put some padding on it. Margin top, let's say 3. Now it's margined from the top. Now we are ready to submit our form, but first let's bind some values to it. First, we can use our getters by typing name and age, and by binding their values to the getters. Name value is age. One of the best practices is when you have a form, you want to commit a mutation into the store, and then from the store action to use this store value as a form value and send it to your backend, or right now it's the smart contract. So basically you can say on each input I want to invoke this update name method, and on this input I want to invoke update age method, and these methods are defined here below. Update name and update age. Okay, so what these methods will do, they will use the store and commit a mutation to it. So you can say update name and just pass the event that's coming from the input, event.target.value, and this all required to update the name. Of course, later we will need to create this mutation, and here we'll do the same. We'll commit mutation that's called update age, and use the target value, but this time if the target value is available, we are gonna parse it to int, otherwise nothing. Okay, so we need to go to our mutation types and just type date name, and here is the date name, date age, and update age. Once that's done, we'll go into our store and create the mutation. Basically, it's just the same as the previous one, but this time only with name. We're gonna update the name, and here we are updating the age. Like that. So each time we update we type into the input, it should update the values in our store. Okay, let's see if that's the case. Right now doesn't happen anything. It says that the types is not defined. Yeah, I remember. I haven't added these types here. Haven't imported them from the top, but this time we're not. Where is this contract? Yeah, it's here. We need to go one level up and then going down. Okay, we'll go one level up and then we're gonna go into the store and mutation types. Okay, so just refresh to be more convenient. I'm gonna type my name, and as you can see, I have opened the Vue DevTools on the tab for Vuex, and each time I write, it fires a new mutation co-update name. Okay, and for the age, and there's error for the age too. Cannot read property target undefined. Yeah, I think I made a mistake where I forgot to add the E there from the event, and there's as well error. Yeah, because there's I typed point. Okay, so now it should be good. Crossing fingers, everything should work fine. Yeah, you can see age and name. And in the next part, we are gonna set data to the contract, and later on we're gonna fetch it, and every account will have its own state. We are ready to set our handler. In Vue.js you can bind methods when a button is clicked by just typing add, clicked, and typing the name of the method. For example, let's call it setData handler. Okay, we're gonna need to create this setData handler here, and if we want to prevent user to submit a blank form, we can do like this name and this age. We can console log form submitted to see if the method is bind good, and going back into the form we can type employee, let's just use John 12. You can see the form is submitted, but if some of the fields is missing, we cannot submit the form because we just made some basic validation. So we would just leave John 12 and form is submitted. The next thing to do is to create a method which handles the submission of the form all the way to our contract. So basically we need to create set data function, which will use our storage contract. And this is our storage contract, and Truffle contract library provides a lot of functions. One of them is the ability to code deployed, which returns a promise. It gets the deployed version of our contract. Usually you can use it without Truffle contract library, but every time you need to remigrate your contract, you need to swap the address. For example, if I migrate it like second time, and if I haven't changed the contract, you can see it won't migrate it because it says network up to date, but you can force it by typing reset, and basically the address here is different than address here. And if you don't use this Truffle contract library, you need to change it every time. So basically, if you just call deployed, it knows, it keeps track of the address of the latest deployed contract, and it returns it when the promise is resolved. So we can change chain function after it and say what we want to do with the current instance of the contract. And of course, we want to do some asynchronous calls, so better we put async here. And what we want to do, we want to set the data of the contract. So let's first see what our contract accepts. So our contract accepts name and age, and the function is called setData. So basically how this works is that we can wrap the call, the asynchronous call to the contract in a try catch block. So if something fails, we can easily see it or console log it. So we're gonna type instance set data and pass the current name and the current age of the person. And as the last argument, this instance on the contract basically accepts the parameters. For example, the parameters can be like which account sends the transaction, and or like the current gas that can be used. But right now I'm gonna just leave the from field and write some catch block console error. So if there's an error, the console will log it, and after that we can just say console we are ready. Or just say success for now. One thing I forgot to mention is that in order to use the storage contract as it is right now, you need to set the provider the same way that we set the provider to the Web3 here. The provider, we set it up to reflect the current MetaMask provider. The same way we need to set the provider to the storage contract. It needs to know to which network it belongs. So basically, we can say right here, set contract provider as a method, as an action, sorry. We can say set contract provider, and storage contract, it has a method set provider, and here we can just use current provider from the Web3. Of course, this is not invoked anywhere, so basically we need to find the appropriate place for it. For now, I think the appropriate place for setting the contract provider is here by typing setting contract provider, and I think it should be fine. Let's test it in the browser. We are ready to test it in the browser right now. So let's see how it works. One thing I forgot to do is to invoke to dispatch the action, because currently we only console logged that the form is submitted, but actually what we want to do is store, dispatch an action, and the action is called set data. Remember, we are not passing any arguments to this set data action, because all the arguments they are in the state. So basically we are getting the arguments from the state here and here, and we are invoking the set data function. Okay, so we are gonna refresh the application one more time, and we can try with John, which is 19 years old, and go to the console and hit save. Right now what happens is that MetaMask pops up and asks us to confirm the transaction, and this is because we are modifying the blockchain. Every time you are modifying the blockchain, MetaMask opens the pop-up and asks you to confirm, because every modification, it costs gas, no matter of what. So basically we are confirming now the transaction, and it said success. So we can see that when we refresh our application, nothing happens, all the data is gone. So we're gonna fix it now. So how to fix the disappearing name and age when the application refresh? What we need to do is, when the account has been changed, like we do here, we commit a transaction to we commit a mutation to update our account with the current active one. But what else can we do? One thing is that we can dispatch an action here. Actually, we can use this dispatch function because we destruct it here. We can set get initial data. Basically, what this will do is that this will serve as a seeder of our state when the app refreshes. Okay, so we'll need this here, the commit and the state. So basically, we're gonna make one simple call to the contract, like deploy. You remember that deploy returns the current instance of the contract as the result of the promise. So for sure we're gonna use async await here, and let's think of how can we utilize this. So result is what function can we use to fetch the initial data of the contract. If we go to our storage contract, we can see that we have set data function, which sets the data for our contract. We have get person data, which uses the address and returns the age and the name, and get people's addresses as well. Currently we are not using this, but we can use it in the later videos. So let's use this get person data and pass an argument like the current address. Okay, we can use the instance and type get person data and pass the current address, and do not forget to add await, because this returns a promise and it's important to wait for the promise to resolve. So right now I'm gonna console log the result and see what it's returned from the server. So right now we can see that the return values are John and big number. This is just a object representation of his age returned from the contract. So we for sure know that we have two returned values, and we can utilize as well here the destructuring. The result, we know that the first one is the name and the second one is the age. So basically, by typing name and age, it's more powerful. So basically we can just console log it to make sure it returns the same values. And yes, the name and the age. Okay, so the next thing to do is actually to update our store values. Basically what we're gonna do is to commit a mutation with name and age. With name and age. So it updates our state. Okay, let's see how it looks for now. If we refresh our application, you can see that it appears on the screen, because when we watch the Web3 account for changes, it invokes the dispatch action and the get initial data action, and this makes a call to the contract and get the current name and age. So basically, if we try to change the account, the name and age disappears. We can remove this 0, like it is the default value for integer. We can remove it by typing here, if the age is 0, then do nothing, otherwise return the age. Yes, right now it's working, and let's see it in action. So we can type George, age of 29, hit save. MetaMask asks us for confirmation of the transaction, which tries to modify the state of the contract. If you're reading only from the contract, there's no gas fee or paid transaction, so you're okay, but we want to modify the state, so we're gonna confirm it. It says success, and yeah, this is some nice feature from MetaMask, which shows that the transaction is being confirmed. And we can switch the account now, go to account number 1. We can see that the name of the account number 1 hasn't been changed, John, 19 years old. And if we change to account number 2 right now, we need to see George, which is 29. And that's correct. We can try one more time to, for example, to change the name of the person. Let's say George has been changed to Abby, and MetaMask asks us to confirm the transaction. We are confirming the transaction, and we can refresh the page. Actually, we can change the name of Abby to Donnie, to Polly, and let's make Polly 20 years old. We're committing, and once we refresh the page, it says Polly. So basically, we are good to go. And when we are changing accounts, the data persists. If we go to the third account, it's blank, and you can say here Ciara, for example, like the singer. 30, submit and confirm the transaction. Success. So basically right now, if I refetch, it will say Ciara, and this is our first decentralized application.